It's one of the world's most popular fruits, found in lunchboxes and kitchens everywhere, but the humble banana holds a surprising secret. It is naturally radioactive. Yes, the same fruit you slice over your cereal or blend into a smoothie contains radioactive elements. Despite this, they look normal, taste normal, and are eaten every day by millions of people without a second thought. This isn't a modern phenomenon or a result of some industrial accident. It's a fundamental property of the banana itself, woven into its very biology. Walk through any supermarket, and you'll see them piled high, with no special handling instructions, no warning labels, and no visible signs of their radioactive nature. This is because the radioactivity in a banana is not the scary, artificial kind we often see in movies. It doesn't come from industrial pollution, nuclear waste, or any form of external contamination. Instead, it comes directly from nature itself. It is an intrinsic part of the natural world, present in the soil where the banana plant grows, absorbed through its roots, and concentrated within the fruit as it ripens. The word radioactivity often conjures images of danger, disaster, and hazardous materials, but in scientific terms the word has a much more neutral meaning. It doesn't automatically equate to harm. Radioactivity simply describes a natural process where the core of an atom, its nucleus, is unstable. Because it's unstable, it seeks to reach a more stable state. To do this, it releases excess energy over time, a process known as radioactive decay. This release of energy is what we call radiation. Think of it like a tightly wound spring slowly uncoiling. The potential energy is there, and it's released gradually. This process is happening all around us, and within us, all the time. This fundamental process of atomic decay happens everywhere in nature. It's present in the rocks and minerals that make up the Earth's crust, like granite. It's in the air we breathe, which contains radioactive gases like radon. It's in the soil that grows our food, and consequently in the food itself. Even living organisms, including plants, animals, and our own bodies, contain naturally occurring radioactive elements. We are constantly bathed in a low level of radiation from the ground beneath our feet and from cosmic rays originating in deep space that shower our planet. Radiation is not an intruder, it is a constant, unavoidable, and entirely natural background feature of our universe. So, what makes bananas specifically radioactive? The answer lies in one of their most famous nutritional components, potassium. Bananas are well known for being rich in this vital mineral. Potassium is an essential electrolyte, which means it plays a critical role in conducting electrical signals throughout the body. It is absolutely required for the proper function of our muscles, allowing them to contract and relax. It's crucial for our nerves to transmit impulses, and most importantly, it helps maintain the steady rhythmic beating of our heart. Without sufficient potassium, our body simply cannot function correctly. The key to the banana's radioactivity is that not all potassium is the same. In nature, the vast majority of potassium is stable. However, a very small, consistent fraction, about 0.012%, exists as a naturally radioactive isotope called potassium-40, or K40. An isotope is just a variant of an element with a different number of neutrons in its nucleus. This tiny difference makes the K40 nucleus unstable, while its more common cousins are not. This specific isotope is not a recent creation. Potassium-40 is a primordial radionuclide, meaning it has existed since the formation of the Earth and our solar system, forged in ancient stars billions of years ago. The reason potassium-40 is still around today is because it decays at an incredibly slow rate. Its half-life, the time it takes for half of a given amount to decay, is approximately 1.25 billion years. This means that over immense geological timescales, it releases its energy very, very gradually. Each decay event emits a tiny, minuscule amount of radiation. Because bananas are naturally rich in potassium, they inevitably absorb both the stable and the radioactive forms of the element from the soil. As a result, every banana naturally contains a small, predictable amount of the potassium-40 isotope, making the fruit itself slightly radioactive. Now for the most important question. How much radiation are we actually talking about? The amount of radiation received from eating a single average-sized banana is extraordinarily small. It is measured using a unit called the sievert, which accounts for the biological effect of radiation. Specifically, one banana exposes the human body to approximately 0.1 microsieverts. A microsievert is 1/millionth of a sievert. To put that number in perspective, it is an almost infinitesimally tiny dose, far below any level that could be considered remotely harmful. It's a measurable amount, which is why we can talk about it, but it is functionally negligible in the grand scheme of our daily radiation exposure. To truly understand how small that 0.1 microsievert dose is, we need to compare it to other more common sources of radiation exposure. For instance, a standard medical chest X-ray, a routine diagnostic tool used millions of times a year, exposes the body to about 100 microsieverts of radiation. That's 1,000 times more radiation than you get from eating one banana. Or consider taking a long-haul flight. Flying at high altitudes reduces the protection from Earth's atmosphere, exposing passengers to more cosmic radiation. A single transatlantic flight from New York to London exposes a passenger to around 40 microsieverts, the equivalent of eating 400 bananas in one go. Let's bring the comparison even closer to home. Just by living on planet Earth, the average person is exposed to a constant stream of natural background radiation from sources like rocks, soil, and cosmic rays. This daily dose amounts to about 10 microsieverts every single day. This means that over the course of a normal day, you are naturally exposed to the same amount of radiation as you would get from eating 100 bananas. Therefore, eating a single banana adds only about 1% to your typical daily radiation dose. In essence, the radiation you get from a banana is a tiny drop in the vast ocean of natural radiation you experience simply by existing. The concept of a banana's radioactivity is so well established, and the dose so consistently small that scientists and science communicators sometimes use it as an informal unit of measurement. It's called the banana equivalent dose, or BED. This isn't a formal scientific unit but rather a useful educational tool to help put different levels of radiation into a context that people can easily understand. It works by comparing a given dose of radiation to the number of bananas a person would need to eat to receive that same dose. It's a simple, relatable way to demystify the numbers and provide a tangible sense of scale for an otherwise abstract concept. Using this handy comparison, we can see just how insignificant the banana's contribution is. As we've seen, one chest X-ray is roughly equivalent to eating about 1,000 bananas. A mammogram is about 4,000 bananas. More advanced medical imaging, like a full-body CT scan, can deliver a dose equal to eating tens of thousands, or even up to 100,000 bananas. The maximum yearly dose permitted for workers in the United States who handle radioactive materials is 50,000 microsieverts, which translates to a banana-equivalent dose of 500,000 bananas. These comparisons clearly illustrate that the radiation from a single banana is trivial. Given these numbers, it becomes clear that the radiation from bananas cannot realistically cause any harm. To receive a dose of radiation high enough to cause the first signs of acute radiation sickness, a person would need to consume somewhere around 10 million bananas in a very short period of time. Even to reach the legal annual limit for radiation workers, you'd have to eat 500,000. The sheer physical impossibility of such a feat makes the radiation risk from bananas a purely theoretical concept. Long before the radiation could ever become a concern, you would face far more immediate and severe health problems. Long before the cumulative radiation dose from bananas could ever matter, the human body would fail from much more mundane issues. The most significant would be potassium overdose, a condition known as hyperkalemia, which can disrupt heart function and be fatal. However, even this is unlikely for a healthy person, because the human body is incredibly efficient at regulating its internal environment. This process is called homeostasis. Our kidneys are experts at filtering out excess potassium from the blood and excreting it to maintain a stable, safe level. Any extra potassium 40 you consume is simply flushed out along with it. The body doesn't accumulate it indefinitely. So, the banana is not an anomaly. It is a perfect example of how radiation is a normal, harmless, and integral part of the natural world. Bananas are radioactive, they are perfectly safe, and in the grand scheme of the universe, they are completely and wonderfully ordinary.